So good evening everybody, and thank you for the invitation back to talk to Clydesdale AS once again. So this next half hour is just supposed to be a little bit of fun. The lighter side of astronomy, it's a few bits and pieces that I've picked up that just made me laugh or made me chuckle, and I hope you feel the same. So we're going to look at the lighter side of astronomers, telescopes, observatories, and probably that's about it for half an hour. I add a miscellaneous, but I don't think there'll be anything beyond observatories. So, some astronomers are scientists. You probably are aware of that, and yes, that's pretty much what's going through my head all the time. So in answer to the question, do you think you have what it takes to be a scientist? In the words of Sir Patrick,
well, we just don't know.
But of course, some astronomers are indeed scientists, some astronomers are astrophysicists. And I assume everybody is sort of happy with the physics that's on the blackboard there. We're going to start from that sort of level and then work our way up a bit in the next half hour. But some people have said, well, if astronomers are scientists and astrophysicists, is there a way we could classify them? Because what astronomers spend some of their time doing is thinking about the classification of stars. And if you look at all the stars that are out there, you see that some are brighter than others, some have different colours. And the Hertzsprung-Russell diagram, which some of you might know about, are a way of cataloguing all these stars and plotting them as a function on the x-axis, as a function of their temperature. Low temperatures on the right, about 3000 Kelvin, higher temperatures on the left, 30, 50, 100,000 Kelvin perhaps. And the vertical scale is a measure of their luminosity, how bright the star actually is. Not how bright it appears, but how bright it actually is. And if you plot all the stars, you see that all the stars are not scattered evenly, they bunch into particular regions. So we have the very hot white dwarfs down here. We have some cooler red giants and red supergiants on the right-hand side, some very luminous stars at the top, and on this diagonal line we have the main sequence. Fairly ordinary stars, for instance, like our Sun, fairly average sort of stars. So if you can catalogue or classify stars according to their colour and according to their brightness, one person thought, well, could you do the same for astronomers? And they came up with the HR diagram of astronomers. And in this particular case, the vertical scale, luminosity, well, we can't measure the luminosity of a person, but if we think of luminosity as being fame, well, you can measure the fame of an individual by seeing how many hits you get when you do a Google search for that particular individual. So if we take an individual, Google their name, make sure we're dealing with the right person, and then see how many Google hits we get, we know where to put them on this vertical scale. And the horizontal scale, just like the colour scale of the real HR diagram, the horizontal scale is backwards, and this is the number of scientific papers that the individual has published. Low numbers on the right, starting from 1, and high numbers going to the left, as you can see, 10, 100, 1000 over on the left-hand side of the diagram. And there are a few individuals that you might know. You're unlikely to know anybody in the bottom half of the HR diagram because by definition they're not very famous. But if we think of the very top left, that individual there, virtually the highest you can get, the most famous, and about as far left as you can get, having published the most scientific papers. So arguably it's the most famous, most scientifically prolific astronomer. I'll just give you a couple of seconds to think, who might that be? I'm not expecting any hands up or anybody jumping in, but you might have guessed who that might be, and the answer is, that is Carl Sagan, the most famous, most prolific scientist who declares himself as an astronomer. Right next door there, who is that? Slightly more famous perhaps, but almost as prolific as scientist, that's Stephen Hawking. If we come further over to the right, we're staying with the very famous people. If we come over to the less scientifically prolific individuals, but almost as famous, that's where we find Brian Cox, a media star, not quite in the same league in terms as a scientist as Hawking and Sagan. And for some reason I don't quite understand, right over on the right-hand side of this diagram, an individual has been included who is almost as famous as those three people, but scientifically output, well, there isn't technically a zero when you're dealing with a log scale, so that star ought to be way over to the right. That's ClAS. Not a scientist, but I guess she has introduced some programs. She's a TV presenter, amongst other things, and that's why she's on the diagram. You might notice a few other individuals you know, Neil deGrasse Tyson, Chris Lintott, Jocelyn Bell Burnell, for instance, scattered in that top third of the diagram. I thought this was quite interesting. But once I saw this, the first thing I thought, being an egotist, is, I wonder where I would be. Because in principle, I'm a scientist, therefore I produced scientific papers. And anybody can Google themselves and find out how many Google hits they get. So I thought, right, let's just see, just for the sake of argument, where would I be on that diagram? So I Googled myself. Steve Barrett is not good enough because there's too many Steve Barretts in the world. Dr. Steve Barrett isn't good enough either because there's a Dr. Steve Barrett in America who gets quite a few Google hits, and I didn't want to steal his. So I ended up searching for Dr. Steve Barrett Liverpool to try and narrow it down to only me. And then Google told me after a little bit more than a third of a second that there are approximately 5,000 hits. So I thought, right, okay, 5,000 hits on the vertical axis. I've published a little more than 100 scientific papers. So where does that put me? That puts me there, right in the middle of the main sequence. So this tells me what I have actually known all along. I am a completely mediocre scientist. Fantastic. Okay, let's have a look at a few cartoons. This one I quite like. Two cavemen, one looking through the hollow log, saying, no, moon looks the same. Is this the most powerful one you have? It's a nice cartoon, it's got a nice theme, but the reason I actually like this one is not because he's looking through a hollow log expecting the moon to be magnified. It's twofold that I like this. In the background there is another telescope, correction, there is another hollow log, but this hollow log, notice it has a little finder log strapped to it to make it easier to find objects in the night sky. You find them in the small hollow log and then you'll find them in the large hollow log. Nice idea. The other reason I like this cartoon is because clearly the caveman on the left is thinking of buying one of these telescopes. They have the price tags on them. But I like this because the caveman on the right is clearly the salesman. You can tell that from the hairstyle, and you can tell that because this caveman is wearing a tie. Great, fantastic. Some ancient astronomical devices, such as a sundial, for instance. Here, the owner of a sundial is observing the fact that the sun is going into eclipse, and then everything goes dark, and the sun is fully eclipsed, and then the sun reappears again. At which point, he has to ring the sundial repairman, or bring the sundial repairman in. Why? Because, he explains, well, immediately after the eclipse, it just keeps blinking 12 o'clock. Another wonderful modern take on the old sundial. And of course, we all recognise this ancient astronomical device. Well, we're not too sure whether it's a clock or a calendar or a mix of the two. But here, one individual in the bottom right there is telling the other, one thing we have to remember with this, of course, is that at the end of summertime, we have to give everything a slight turn to the left. Yeah, they had summertime even in those days. It's a complete mystery as to how they moved these blocks. Maybe we think we understand how Stonehenge was built in terms of moving these blocks around. Here, one individual is saying to the other, how did they move these massive stones? And again, Sir Patrick might say,
well, we just don't know.
But the hint in this case, the clue that tells us how these large blocks were moved in ancient times, is given by what is now appearing on the left-hand side. That's the hint that tells us how it was done. Let's have a look at a few astronomers, maybe not all of them, let's just pick out two or maybe three and have a quick think. Galileo. Not only an astronomer, but of course a physicist, well known for the fact that, apocryphally, he dropped cannonballs off the Leaning Tower of Pisa, a large one and a small one, and noticed that they hit the ground at the same time, whereas previous scientists or philosophers had said, no, the heavier one will clearly hit the ground first. And the question is that true or not? Galileo, rather than saying what should happen, decided to make measurements, dropping cannonballs and timing how long they took. Of course, you need some precise timing. Galileo didn't have much more than his own pulse to judge the timing of very closely spaced things happening in time. And it's sometimes been asked, well, would things have been different if Galileo had had access to computers? Would it have made a difference to the way Galileo did his experiments? Would they have ended up being more precise? But cynics have said, well, no, if computers were available in Galileo's time, he would have ended up throwing the computers off the Leaning Tower of Pisa and seeing which of those hit the ground first. What about Newton? Everybody knows the story. Newton and his apple sitting under a tree in the orchard outside Woolsthorpe Manor in Lincolnshire. Apple falls and either hits his head or falls in front of him, and he starts to think, why does the apple fall to the ground? And he develops his theory of universal gravitation. So everybody is familiar with Newton discovering gravity under the apple tree. What is not so widely appreciated is that later that same day, Newton also discovered comedy. And for those with a wicked sense of humour, you could say that a little while later it went even further and Newton discovered surrealism. And that, I thought, was amazing, the idea of a grand piano falling out of an apple tree. Brilliant. What about this chap? We mentioned him in the HR diagram, the Hertzsprung-Russell diagram, in the top left, the most famous, the most prolific astronomer. And people, of course, remember him for his Cosmos series back in the 1980s, I think it was, getting on for 40 or so years ago. And the cartoon by Larson has him pointing to the stars saying, just look at those stars. There must be hundreds of them. And for anybody that doesn't get that joke, you can't have heard Carl Sagan talking the way he does during the Cosmos series. Let's have a look at a few different types of telescopes. That's a wonderful looking telescope. As far as I know, it never actually came into existence, but it's a wonderful looking design. And as far as I can tell, it's designed such that regardless of where the telescope points in the sky, the eyepiece will always be at the same position. So for an astronomer of a given height, regardless of where they're pointing, they don't have to move. What a wonderful Victoriana piece of design. And of course, some amateurs are very good at designing and building telescopes. I don't have many details of this one, but as far as I can tell, it's made of a combination of stainless steel and titanium. It must have been very difficult to work. They're not the easiest metals to deal with. And the result, well, do you really want so many shiny surfaces when you're using a reflecting telescopes? Possibly not. But you've got to admit it's an absolute work of art as well as a functioning telescope. And many amateurs are indeed very talented. Some don't really have a clue what they're doing, but indeed many have produced some wonderful devices. What about the smallest telescopes that are around? Fork-mounted telescopes. Perhaps some of you have got a fork-mounted telescope. Perhaps you didn't appreciate that the smallest fork-mounted telescope is probably a lot smaller than the one you have. It's this one. It's a little telescope mounted to a fork. And the fork is connected to a knife and a spoon, making a very nice little stable tripod. So I guess that probably is the smallest fork-mounted telescope in the world. And whilst we're in small telescopes, what is probably the best telescope in the world as far as the small category is concerned? Well, you can possibly tell from the words. Probably the best telescope in the world is one that's made with a Carlsberg beer can. So in this case, the can had its top removed, a small mirror was placed in the bottom, and the eyepiece has a small 45-degree mirror connected to it, such that when the eyepiece is inserted into the can, it forms a little Newtonian telescope. I am told that it worked as a telescope. No comment was made as to the optical quality of the images that it produced. And when one is not enough, why would you possibly build yourself one telescope when you can build yourself two telescopes and make yourself a huge pair of binoculars? So here we have what appears to be a sort of double Dobsonian, if you like. And you can see from the way it's constructed, the light from the two telescopes comes into this binocular eyepiece here, one eyepiece for each telescope. And so you can judge, roughly speaking, the height of this by imagining an adult individual looking into the eyepieces. Those Dobsonians appear to be something of order 16-inch or so in diameter, but that's not enough for some people. Some will go for a double telescope with, I would guess, something like 20-inch, half-metre or so mirrors. And you can appreciate that with this longer focal length, the eyepieces are now up here somewhere, and therefore to use this telescope, almost certainly you would need some sort of steps or step ladder in order to reach the eyepiece when the telescope is pointing at the higher parts of the sky. For some people, even two isn't enough. And for some people, rather than think about can we get enough money for a nice telescope with a very large aperture, they take a different approach and say, well, we're not going to get all the money at once, so rather than build or save up enough money for a very large aperture telescope, why don't we get more modest, still many thousands of pounds, but why don't we get a more modest telescope, such as a telephoto lens here, and put a camera on the back, and if money allows, we'll just buy more and more and more of them, and you could do that, and you could end up with 10 of these telescopes with 10 cameras on the back. Here they are mounted onto a large equatorial mount. That has the advantage, not only can you buy it piecemeal and still end up with a large aperture, but you have the advantage that you're taking, with 10 cameras on the back, you're taking 10 images simultaneously, and you can either take the same thing 10 times over, or you can have a couple of cameras taking H-alpha and a couple of cameras taking oxygen, or a couple taking sulfur and others taking red, green and blue, and one taking luminosity. You have the choice of taking different filters on different cameras simultaneously. And if you're going to build up 10 and money is still available, you just keep going. And if you want 24 of them, well, no problem. You put 24 of them together. I believe this particular group now have 48, but I don't have a picture of that to hand. And size, of course, matters, as we all know, being astronomers. If you want to catch a lot of light, you want the largest aperture you can get hold of. And for some amateurs, that means taking things to what most of us would be considering as fair extremes. So this individual has certainly a very nice vista. One would imagine that's a very dark sky sight, wherever it happens to be. And you can judge, roughly speaking, the size of the main mirror. But I do ask you, would you really fancy being on top of that particular stepladder in pitch darkness, trying to align to a particular distant object? So each to his own, I guess. And what about the largest refractor ever made? We're moving away from amateurs now and just thinking about the largest refractor. Until fairly recently, I assumed that was the 40-inch Yerkes refractor in Wisconsin. But actually, it was this one. The front element of this particular telescope is about 48 inches or so in diameter, a little bit larger than the Yerkes refractor. The telescope was so big it had to be permanently mounted on a set of pillars, and it would look at different parts of the sky because of this siderostat, this movable mirror, which would take light from different parts of the sky and send it down the telescope. This panel at the top shows you how it worked during the Great Paris exhibition of 1900. Light from a distant object, sun, moon, or in principle stars, would bounce off the mirror and then go down the telescope, which is mounted horizontally in this large building here. And then if an eyepiece was placed at the end, you could use eyepiece projection to project an image of the sun or the moon or other objects. And in a darkened auditorium, I'm sure that the vision of a large portion of the moon and its craters being displayed on the screen there must have been very impressive. So this shows you one end of the telescope. There's the other end of the telescope mounted on wheels so that you have a little ability to focus. There's a slightly different view looking down the building, and here you can see the business end, the objective lens is at the far end, and here we have a photographic plate holder, and the plates look huge, possibly more than half a metre in size, I'm not quite sure, maybe 24 inches or so across, so enormous photographic plates, but that could be replaced with an eyepiece holder to do the eyepiece projection. I couldn't actually see the eyepiece itself. This image was simply labelled as the eyepiece holder, so presumably a relatively large lens was placed there to capture the light and project it into the auditorium. So a little bit bigger than the refractor in Yerkes Observatory, but as far as I know, after the exhibition finished, the telescope was simply scrapped. The objective lens went into a museum and the rest of the telescope was simply melted down. Shame. Not everybody, of course, works in metal. Some people work in wood. And one individual said that they wanted to reproduce life-size the Hubble Space Telescope. They needed a big garage, a big warehouse to do it. But if you're going to build the Hubble Space Telescope, why not do it in plywood? An obvious thing to do. Yeah, of course. Some people work on a smaller scale in wood. It looks a little bit like a Dobsonian, but it looks a little bit like a cannon as well when seen from this particular angle. But you can see the amount of love and care that people put into the craftsmanship into some of their work. Some would prefer to simply buy an optical tube assembly off the shelf, as it were, but here a person has taken an OTA and built themselves a wooden equatorial mount and then taken a standard optical tube assembly and put it in this fork mounting. A well-known amateur astronomer of old is Russell Porter, who built telescopes not only that were very functional, but some of them were just beautiful ornaments. Here, a garden telescope where the primary mirror you can't quite see in this area here, and a small 45-degree mirror and a tiny eyepiece. So it was a garden ornament, but it was still a functional Newtonian telescope as well. And of course, some people build their telescopes and some people want an observatory to put their telescopes in. Having put a certain amount of effort into their telescope or a certain amount of cash into buying one, they want an observatory to put it in. What better place than the Palomar Observatory? What a beautiful setting. I visited that observatory. That's the dome for the 200-inch or the 5-metre Hale telescope. I went there in 1982 when I was a student. I think I've still got that shirt and probably those shoes as well, but in 1982 I visited the Hale telescope and I thought, that's impressive. One day I'm going to own a house with a garden big enough to build that in the back garden. Okay, great aspiration, but I had to downsize my aspiration somewhat, and 16 years later in 1998 I had a house which was just about big enough to have an observatory in the back garden, and I decided on an 8x6 B&Q shed, which I converted. Not quite as spectacular as the Hale dome, but you've got to go with what you've got to get. Inside that particular observatory, I had the roof hinged so I could access the sky, and you can get an idea of the vintage there, not necessarily from the 8-inch Schmidt-Cassegrain telescope, but you can judge it from the fact that the laptop looks like a brick rather than a rather thin thing that you would get these days. Some people put a huge amount of effort. I bought a B&Q shed and converted it to an observatory, but you can see that some people put their heart and soul into building an observatory in their back garden. I can't quite judge exactly how big that is. Maybe gardeners can tell from the size of the flowers in the foreground there, but you can see the amount of effort that's gone into making that geodesic dome rather than simply buying a fiberglass dome or doing it any other way with more regular sort of shapes. So a beautiful amount of craftsmanship. But of course the one problem, even if you've got a telescope and you've put it into your back garden, then that's not necessarily ideal because it depends where you live. If you live in a light polluted area, then having a telescope in your back garden is very convenient, but it's not necessarily the darkest skies. Wouldn't it be great if you could simply take your observatory with you, such that you could go to wherever you've got dark skies and you would be able to take the observatory with you? Of course you can't do that, unless you put the observatory and build it into a caravan. Great idea number 36. What a fantastic idea. Half caravan, half observatory. You tow that to wherever you want to do your observing, or you go on holiday to wherever you want to go. And if you get some nice dark skies, you do your observing for as many hours as you want. And when you're finished, you collapse into bed. You don't have to worry about the fact that the accommodation and the observatory have been separated. Wonderful idea. I guess for some of us, we may not have a car that's big enough to tow a rather large Leviathan like that, so maybe that's not suitable for everybody. So what's the alternative? Well, you can get a smaller portable observatory. That's the sort of thing you could go for if you wanted something a little bit smaller and you just wanted for it to protect perhaps a small telescope, rather than get 16 of your friends in there and have a little star party. As well as little portable observatories, you can of course get go-to telescopes. Here's a wonderful telescope on wheels. I don't know if you need a license to drive this thing. It appears to be on an equatorial mount, and I presume you can take that wherever you want to go to do your observing. It's by no means the earliest design of go-to telescope. I found this one, which is very interesting. Something of order 8 or 9 inch refractor, I believe, mounted atop a car. I'm not sure of the vintage. I don't know if this is the 1950s, but I really can't pin down the date. You might say that's ridiculous, putting such a large telescope on a car. For instance, it would be fine in principle for looking at the horizon, but you couldn't point it up in the air because of the car roof. Well, not true. You can actually crank the handle which raises the central pier, which allows you to use that telescope not quite to the zenith, but certainly to very high altitudes, very high elevations. But you might still look at that and say, well, that's still crazy. The car can't be stable, surely. And a telescope of that size, nobody in their right minds would actually, for real, this was probably a publicity stunt, nobody for real would actually put a working telescope on top of a car. Unless you come from America, in which case it makes perfect sense whatsoever. And again, we see something like maybe 6, 7, 8 inch refractor, very long focal length from the appearance of it. In this case, mounted on top of a Volvo. I believe this individual lived in Florida at the time, and I'm guessing that he would drive around to dark skies and use this particular beast. Notice the back bumper of the Volvo's got a little bit of wood jacked underneath it, presumably to stop the Volvo moving whilst observations were being made. Is that the largest example of a telescope that was made to be mobile? Well, not quite, but now we're getting well out of the range of amateurs, and of course what we have here is the Stratospheric Observatory for Infrared Astronomy. Basically, stick a telescope in the back of a 747. If you're NASA, you can afford to do that, but if you're anybody else, that's a little outside the range of most amateurs. And I think we've got to the point now where we'd better stop, and I will acknowledge the various sites from which I've taken cartoons or other material. So thank you all for listening.